Right now it's Thursday afternoon, December 10th. We're in week 2.5. This video is, I'll tell you here in a second. This video is courses. Either one of these should all be the same. PS25CBlake followed by 25DBlake. PS25CBlake. Okay, and we're talking about ionic bonds, covalent bonds, metallic bonds. Metallic bonds make alloys, not compounds. So we don't have to talk about those much more in this chapter. Covalent bonds make molecules, they make compounds, but they're more complicated to do than ionic. We're going to spend our time with ionic. If you took our organic chemistry class, let's say if you wanted to be a pharmacist or a doctor or a chemical engineer or, I don't know, something in the medical field, a lot of things in the medical field, you might want to take our organic chemistry course. And we spend a lot more time on more complicated molecules there. But we're going to be talking about ionic bonds in this course, and in chemistry course we focus more on, in next year's chemistry course we focus mostly on ionic bonds. Okay, so we're talking about writing chemical formulas and naming compounds. To do this we need oxidation numbers. It tells you how many electrons an atom is going to give or take, and we'll give you a table for that so you don't have to know it. There is one in the book from page 566, figure 17. And those oxidation numbers, we don't know, you have to figure out what it's going to be for the transition metals. But for the rest of these elements, called representative elements, they're pretty much 1 positive, 2 positive, 3 positive, 4 positive, 3 negative, 2 negative, 1 negative, and 0. We don't have to worry about the noble gases. They don't do reactions, they don't make compounds. So I'm going to add these oxidation numbers to the periodic table that we've been using, which looks like this, except now we've got the oxidation numbers in 1 positive, 2 positive, 3 positive, 4 positive. Takes 3, takes 2, takes 1, and none. So these are negative. You don't have to have these memorized. I'll provide you with these oxidation numbers on a table. Okay. So we are going to talk about, these are the rules that the book uses for naming binary ionic compounds. For now, I'm going to skip these and coming back to them. I've got a little bit simpler way I'm going to do it to start. And we're going to do it this way. This is what I introduced last Friday and last Monday, and everybody pretty much got it right away. You're going to do 3 things. You're trying to match the number of valence electrons given and taken from the opposite ends of the table. Those are the only compounds we're going to work with. Metals that give, nonmetals that take. That's what we're going to focus on. You're going to use the fingers to count these valence electrons, and you're going to try to match them up by changing the atoms and changing the numbers on the subscripts. Okay, I'm going to come back to this maybe later. But we're going to do the binary compounds made of only 2 elements. To do this, we will start with a worksheet. Now, if you're at home, you don't have the worksheet, but it looks like this. It has a top half and a bottom half, and you'll get one. But you can simulate it just by writing, just write these on the paper. So we want to circle the ones that are binary, and they are ones that have names that end in "ide." So we want to name the binary ionic compounds. The binary ionic compounds just have 2 elements in them, a metal and a non-metal. 1 capital letter, 2nd capital letter. If there's lowercase letters, they go with the capital. So these have 2. Something that's not binary would be something like chalk, CaCO3. Now it's 1, 2, 3 capital letters, 3 elements. 3's not 2. So binary is 2 elements. The ones at the top of this page, and you can write these down, that are binary, there's 9 of them there, are these 4. So take a moment, write these 4 down, pause, ding, ding. Write these down, and then name them. All they do is they have 2 names. They have a first name and a last name. You look at the periodic table and you find that sodium. The second name you look up is chlorine. But you change the ending to "ide" when it's binary, when there's just 2. So this is sodium chloride. If you look on your periodic table, magnesium is on the left. It's about, let me pull this up here. Uh-oh. Magnesium is about here, and fluorine is about here. So it's magnesium fluoride. That's how you do those. So how do you do the other ones? Well, B2O3 is boron. Boron's about here, and oxygen's about here, so it's boron oxide. And the last one on that worksheet, try naming this one SrBr2. Sr is about here. Find it on a periodic table. Br is about here. And strontium and bromine. So you're going to change that to strontium bromide. Chop off the end of the second name and add an "ide." Okay, then we'll do the reverse. Go to the bottom of the worksheet. On the bottom, at the top of the worksheet, you're starting with chemical formulas and coming up with the names. That's a little bit easier, but once you've done that first, we'll go to the bottom of the worksheet, start with the names, and come up with the chemical formulas. On the bottom, you today only do the ones that are binary. These ones here, I'm editing this to make it better. These ones are not on your worksheet. They will be on the worksheet next year, which does nothing for you. Okay, so ignore these ones for right now. There are 4 at the bottom that are binary. How can you tell they're binary? Because they end in "ide, ide, 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 ide." So those are the binary ones. The other ones don't end in "ide." They're not binary. So how do you write their names? Well, you look up the 2 things. Hydrogen sulfide. Hydrogen's over here in the give 1 family. Sulfur's over here in the oxygen family, taking 2. This has an oxidation number of +1, oxidation number of -2. These don't match. And going back to what we talked about, we want to make the matches. We want to make matches. Match. So how do you make the match? Okay. Hydrogen gives 1, sulfur takes 2. Well, you have to get another hydrogen. We did this the other day. So it becomes H2S. Potassium chloride. Potassium is about here. It's right under Li, a couple positions. Chloride is over here under fluorine. So this gives 1, its oxidation number is +1. This takes 1, its oxidation number is -1. It's a match. It's just LiCl. Not LiCl. LiCl is lithium chloride. Potassium chloride is KCl. The next one, below that, is sodium iodide. Sodium is here, right underneath lithium. Iodine is a few positions below fluorine. This has an oxidation number of +1 gives 1. Oxidation number of -1 takes 1. It's a match. It's one of each. As a matter of fact, sodium fluoride is one of each too. Which is why I'm changing these, because they all ended in 1 and 1 and 1 and 1 and 1 and 1. These new ones are going to have a little more variety. Okay, that's how you do that. So, now I want to go back to number, I'm not going to do these in order. Let's do page 568 practice problems. We'll do 17, 18, and 19 because it wants the names and that's easier. Then we'll do 14, 15, and 16, which is writing the chemical formulas. If you have an AlCl3, Al is about here. If you look up on a periodic table, it's aluminum, and Cl is under fluorine. So you have aluminum and chlorine. You got to end in "ide," so it's aluminum chloride. And then the next one is Li2S. Well, lithium is here, giving away 1 electron. Sulfur is here, taking 2. They don't match. That's why I have to have 2 lithiums. And you got to end in "ide," so it's just lithium, sulfide. And then the last one, got a Cr and an O3. Well, if you look, Cr is up here, right about here. It's chromium, and it's bonding with oxygen, which is over here. So it's chromium oxide, except this is a transition metal. So you don't know what its oxidation number is going to be. You have to figure it out. And you have to tell what it is. So it's not just chromium oxide. So how are you going to know what that number is? Well, oxygen we know takes 2. It's 2 minus. And I have 3 of them. 2, 2, 2. I have 2 chromiums. So if oxygen's got 3 of them, each taking 2, how many did I take? 3 of them taking 2 apiece. 6, which means I gave 6 in order to be a match. If I gave 6, it has to be 3 apiece. So it's got to be chromium 3 oxide. So you put the 3 in parentheses, and that means that's the charge on the chromium ions. Okay, now we're going to do 14, 15, and 16, which is harder. We're coming up with chemical formulas. What is the formula for potassium sulfide? Well, K is here, down below lithium. Sulfur's here under oxygen. K is +1, oxidation number, given 1. Sulfur's taking 2. This is not a match. So I have to have another potassium. It's got to be K2S. What is the formula for calcium chloride? Well, calcium's down here below beryllium, given 2. Chlorine's over here under fluorine, taking 1. This is not a match. How do you make it a match? Get another chlorine. So it's got to be CaCl2. And then, how do you make the formula for lead phosphide? Okay, lead 4-phosphide. Lead is down at the bottom of the carbon family. Its oxidation number is +4. It doesn't have to be, but it is. Phosphorus is under the nitrogen atom. its oxidation is 3-, so it's taking 3. Giving 4, taking 3. How are we going to match this up? 4 and 3. Well, if we move 12 electrons, we can do it. If we have 3 atoms giving 4 apiece, and 4 atoms taking 3 apiece, we have 12. So it's PB3, P4. That's how you do that. So this was PS25CBlake.